Hey, Chan Physics, this is Mr. Block and a video on Waves 1. So Waves 1 is right here. First question just asks us the definition of a wave. A wave moves energy. And so most of the times the particles themselves don't move. It's just the energy of the wave that's moving. Okay. So the second two problems right here, they're asking what kind of waves do we see? And then a couple questions about that. So the first thing is what type of wave do we see? So we see this tuning fork right here creates this compression of air molecules. So they all squeeze together and then they all get real wide apart and then they squeeze back together again and they're all wide. So this is a longitudinal wave. So we study about the longitudinal wave as a sound wave. And so the first thing is what kind of wave this is. Is a longitudinal wave. Right, and then it says label the compression and the rarefactions. So here are the compressions where the air molecules are all together. So these are the compressions. And then the rarefactions are where they're all wide apart. So we can see them all right here. So all of these are the rarefactions. Okay, and it says what is the wavelength. So what we have here is we have a measurement, and so the measurement looks like it's 32, but there is not just one wave here. There's from compression to compression 1, 2, 3, and then 4. So the wavelength is the total 32 centimeters divided by 4, or 8 centimeters. So the wavelength is 8. All right, so the next one right here, this is where we're looking at a transverse wave. And so a transverse wave, the items don't compress like the air waves. Instead, they move perpendicular to the wave. So the wave is moving from left to right, but the particles are moving up and down. So the first thing is what type of wave this is. This is a transverse wave. Label the crests. So the crests are right here. So the tops are the crests, and then the troughs are the bottoms. So here's the trough. And how many wave cycles are drawn. So if we go by how it repeats itself, it starts going up, all the way down and up. So that's 1. And then so it looks like another 1/2 and then another quarter. So I get 1 3/4 for how many waves are shown. And I think that's what it says in the 1.75 in the key. And then what was the wavelength of the wave? And so we're just going to take the total. We can take the total, but the total isn't at this part right here. So instead, to find the wavelength, we'll just say, well, what's the length of one full wave, which is right there. So 8 is the wave is the length of one full wave. And then it says, what is the amplitude of the wave? Well, the amplitude looks like it's going up to 2 and down to -2. So we would take 1/2 of 2 minus a -2. And so that's 1/2 of 4. So the amplitude is 2. All right, and that's what it says right there. Okay, and so the same thing here. We've got the crests on the top, the troughs on the bottom. We've got a transverse wave. How many waves do I see? I see 1 right up to there, then 2, then 3, and then 4. So a total of 4 waves there. So 4 waves. And they ask us then, what's the wavelength? Correct? How many wavelengths? What's the wavelength? So the total length right here is 1 meter or 1 centimeter. So one wavelength would just be 1 centimeter divided by 4, since there's 4 in the 1 centimeter, or 0.25 centimeters. And then what's the amplitude? It looks like giving us a total distance traveled of 0.4. And so 1/2 of that, right? Because it's 1/2 the high minus the low. So if this total is 0.4, then it's going to be 2. So the amplitude is 0.2. All right. So if we then go to what they're asking us here in this one right here, it says you and your friend are doing some things, you measure some times, and you measure some distances. And so they ask us some questions about them. So it says, what's the wavelength? Well, the wavelength is just what it is from crest to crest. So the words say that you measure from crest to crest and you get 12. So the answer is one wavelength is 12 centimeters. Then they ask us what's the period of the wave. So remember, period is capital T. And since they said that we measured 9 seconds for 10 waves, so we say, well, there's 9 seconds divided by 10 waves, and we get 0.9 for one wave. So 0.9 seconds for one wave. And then what's the frequency? Well, the frequency is just going to be 1 divided by the period, or 1 divided by 0.9. So that's how we do that problem. All right. And then the last one right here, same idea. I think they're asking us amplitude, period, and frequency of this wave. So in the key, you'll see I even made a mistake. It's like point, you go down, you go up, and you go down. And so this is where the wave starts to repeat itself right here. And so if you think about it, if you cut right there, then the next wave starts right there, and the next wave starts right there. Okay, and so if we wanted to find the period, well, we would just take from here down, and I think we're saying that that's 0.6. Okay, so the period in time is 0.6, so t equals 0.6, and then we want the frequency, so we'll just take 1 divided by 0.6 to find the frequency, and then the amplitude. We're going from 12 down to 4. So remember, amplitude is 1/2 the high minus the low. So it looks like me to be 4, and then that's in meters, I think. 4 meters is the amplitude. Okay, so that's how we do that problem, and I'll be back for other videos with other sets in a second.